This video is on how to factor non-monic quadratics. Let's go over some of these words first. This word right here, factor. The word factor means to change to parentheses, multiply parentheses. This could include more than two parentheses. All right, and here, this video is going to be talking about how to factor non-monic quadratics. So what exactly is a quadratic? A quadratic is a degree 2 polynomial. This degree 2 part, it's not the exact definition, but you can think of it as the biggest exponent on the variable is 2. That's not the exact definition of a degree 2 polynomial, but that's one sort of way of thinking of it. Okay, and we're not just factoring quadratics, we're factoring non-monic. This non means not. A monic is when the leading coefficient is 1. So a non-monic is when you have a leading coefficient that is not 1. So non-monic. The leading coefficient is not 1. So if we go back to this word quadratic, quadratics have the general form of ax squared plus bx plus c. This is if you put a quadratic in normal form. So like we were saying before, the biggest exponent on the variable is 2. So you have x to the 2 power. Since this is a normal form, this is x to the 2 power, x to the 1 power, x to the 0th power, or no x's. And my leading coefficient is the coefficient or the number that is in front of the x squared. So if that right there, if that number a is not 1, then this is a non-monic. Okay, so let's do an example of factoring a non-monic polynomial. So let's say we have this right here, and you're asked to factor 6x squared minus 11x minus 10. So since we're being asked to factor, we're being asked to change it to parentheses times parentheses. Since this is a degree 2 and you're multiplying two things together, this right here will be degree 1. This will be degree 1. Degree 1 times degree 1 is degree 2. So right here we have something with x times something with an x will give you something with an x squared. How do you do this? My first step, I'm going to find the factors of my leading coefficient. let's find the factors of 6, or what multiplied times what will give me this 6. Well, you have 1 times 6, 2 times 3, 3 times 2, 6 times 1. You also have the negatives of these. Negative 1 times negative 6, negative 2 times negative 3, negative 3 times negative 2, negative 6 times negative 1. For in practice, you can just look at one of these or the other. And even for the ones that are sort of duplicated, like 1 times 6 and 6 times 1, you can sort of just ignore those as well. So now we have these two options. For these two options, you're going to pick one of these two options, and you're going to basically put it here and here. And these are for the factors of 6. Okay, so of these two, pick one of them. This is just at this point sort of a guess. I'm going to choose this 2 and the 3. Later on, I'll explain a way to guess better. But for right now, we're just sort of guessing that when I factor it, this will be a 2 and that will be a 3. Okay. So we just found the factors of 6. Now let's find the factors of your constant. Your negative 10. So you find your factors of your constant, in this case negative 10. Those factors are 1 times negative 10, 2 times negative 5, 5 times negative 2, 10 times negative 1, and the negative or opposite versions of those. So you have negative 1 times 10, negative 2 times 5, negative 5 times 2, negative 10 times 1. I would organize it when you're doing this, like I organized it by starting at 1 and starting to get bigger, and then put the negative versions on the other side. Okay, so if there's a way to factor this, where all these numbers here are going to be integers, you can, at this point, you're going to basically try some of these numbers here in these two locations. Show you exactly what I mean in 1 second, but you're trying these here in these two locations with the goal that this one multiplied by this one plus this one multiplied by this one will equal this number right here. So at this point, it's sort of a guess and check. So we're guessing which of these 8 combinations we might be able to put in here, so that this one times this one plus this one times this one will get you that middle b, that negative 11x. Okay. So just guess one. Let's see if this first one here works. And just for the record here, the order matters. Putting in 1 and negative 10 will get you a different number here than if I put negative 1 and then positive 10. So putting this one or this one will actually get you a different result. Putting this one here or negative 10 first and then the 1 afterwards will also get you a different result. So you actually have to try all 8 in hopes that one of them will work. So let's try this one right here. Let's put positive 1 here and then negative 10 here. Okay, and then check to see if it gets you negative 11. Positive 1 multiplied by positive 3 gets you 3x. Positive 2x multiplied by negative 10 gets you negative 20x. So does 3x plus negative 20x get you negative 11x? The answer is no. So this right here will not work. This is not the factors of this. So erase it. Try a different one. Okay. You do not have to try these in order. I am going to try this one right here. Negative 5 first, and then positive 2. So let's try negative 5, positive 2. Okay. And let's check it now to see if it gets you negative 11x. Negative 5 multiplied by 3x gets you negative 15x. Positive 2 multiplied by positive 2 gets you positive 4x. Negative 15x plus 4x does get you this. Congratulations, you have found how to factor our polynomial 6x squared minus 11x minus 10 equals 2x minus 5 times 3x plus 2. And you basically have to just try until you get the one that works. If you have tried all of these and none of them works, well, now you have to try the 1 and the 6. So instead of it being 2 and a 3, you try 1 and 6. So this does require a lot of guessing and checking and guessing and checking. But there are ways to guess in a better way, to not just randomly guess, but have an educated guess. So how would I make an educated guess on which one of these 2 to try first and which one of these 8 to try first? Let's talk about that. So here's my hint. When you're choosing which numbers to try first, you're going to look at that middle b. So the smaller the b is relative to a and c, the closer your d is to f, your e is to g. What do I mean by that? If you have put it a different way. So here, let's look at this example. The smaller this b is compared to these two numbers, the closer these two numbers will be to each other, the closer these two numbers will be to each other. That is basically what I meant here. Looking at our previous example, so looking at this example right here, where I'm asked to factor this, when I was creating my factors, I looked at that first number, 6, and looked at that last number, -10. So if I have a 6 in front as my leading coefficient, and I have a -10 as my constant, what is the very largest, what is the very smallest b I can get? So this is going to be degree 1 here, degree 1. And what it turns out, to get the smallest b here, if I had 2x minus 2 and 3x plus 5. This 2 and the 3 here, I got from the 2 and the 3 were factors of the 6. This -2 and +5 were factors of this -10. And if I multiply and simplify 2x minus 2 times 3x plus 5, I'll get 6x squared plus 4x minus 10. And that is the smallest b I can get using only integers here. And when I say smallest, I mean closest to 0. What is the largest b I can possibly get? Once again, this will be x and x. And if I used 6x and 1x, so once again, those are the factors of 6 I'm using, and I decide to have it be 6x minus 1, 1x plus 10, with the -1 and the +10 being factors of my -10 there. If I multiply and simplify this, my middle term here will be plus 59x. And that is the largest b I can get using integer values here. And now let's look at this while thinking of this part up here. If you notice here on the left, for my very small b, 4, these two reds were very close to each other. 2 and 3, very close. This -2 and +5, very close. Of all my factors of 6, the 2 and the 3 were the closest. Of all my factors for -10, having a 2 and a -5, or 5 and a -2, that's as close as they can get. They're 7 spots away from each other. And using those closest and closest, I was able to get my smallest b possible. Now, if I have them be very far apart from each other, the 1 and the 6 were further apart, and the furthest apart was the negative 1 and 10. If those are very far apart, I can get a very large b. So if you're wondering why is that when I was factoring this, why is it that I chose this 2 and this 3 to start? It's because this negative 11 is pretty small compared to my 6 and negative 10. And I knew to try one of these 4 here in the middle. I knew one of these 4 here in the middle would probably be the correct one here. Once again, because that negative 11 is pretty small compared to these 2, 6 and negative 10. So that's my hint on how to choose which of these to try first. I want us to now talk about why does this process work? So, here is the most general form we have for a quadratic: ax squared plus bx plus c. I know once again this is going to be degree 1, these 2 different parentheses. Since degree 1 times degree 1 will get you degree 2, let's multiply this part out right here. Okay, so if I have dx times fx, once again, these a, b, c, d, e, f, g are numbers. So if I had dx times fx, that would equal d times fx squared. Okay, and then you go dx times this one here. That'll get you plus d times g x. Then let's do this one, e multiply fx. That gets you plus e times f x. And finally, your e multiply the other one. So e times g, that's just a number times a number, gets you e times g. So this part on the left of the equal sign will equal this part on the right of our equal sign. On my left-hand side, I have one term with an x squared, which is this one. It's my only term with an x squared. And on my right-hand side, this is the only term with an x squared. So what I know is that this d times f, which is this one right here and this one right here, those two will multiply to equal my a. So I know that my d times my f will equal my leading coefficient a. Which is why my first step when I was factoring before, I was finding the factors of A. Okay, let's continue to look at this. On the left-hand side, I only have one term that is a constant, so no x's. On the right-hand side, I only have one term that is a constant, my e times g. So therefore, I know that my e times my g will equal this constant c. So looking up to this part right here, this c is equal to this one here, e times my g, which is why my second step was to find the factors of c, because I know that my e times my g was equal to c. My e times my g is equal to c. All right, and that right there, those two steps, once again, was equivalent to these two steps right here. And finally, I know that here on the left, that bx is the only term, only degree 1 term. On my right-hand side, there are two terms that are degree 1. This one and this one. So I know that my b times g plus my e times f will equal this b. So I know that my e times f, so this one multiplied by this one, plus my d times g, so d multiplied by g. These two terms added together will equal my bx. Okay, so this is the reason here that this works.